which can recognize shapes and act accordingly, has now gone beyond the experimental stage. Since we started filming this program, this type of basic robot has already been overtaken. More sophisticated models which can identify parts have been installed in an American car factory. An even greater challenge is whether we could ever teach machines to obey spoken commands.
This is the Bell Labs Flight Information System. Please dial your identification number.
In a limited way, machines are already being programmed to recognize the human voice.
Please state your flight destination.
San Francisco.
San Francisco. From which airport are you planning to depart?
Newark.
Newark. The following flights are available from Newark to San Francisco from 8 a.m. to 12 noon.
But we are years away before these will be reliable enough to come into general use. After all, this is supposed to reject sounds it doesn't recognize.
On what day of the week are you planning to depart to San Francisco? Saturday. You want complete flight descriptions.
That's beautiful.
But I can imagine that speech recognition is going to grow very rapidly. One can do speech recognition in simple ways with very big computers and research programs today. But as integrated circuits get so they can do everything that the big computer can do, it becomes more practical in a real sense. To have, for instance, transcription on your telephone where you can get a typed copy back of what you said. Maybe with not quite proper English, with maybe some mistakes in interpreting what your words were. But it's someplace in the future.
You'll never get a chip to drown out aircraft noise.
That's right, but, well, I'm not sure.
So we've seen that just about anything might be possible with this exploding technology. Think on this. 10 years ago, on the day that Neil Armstrong first stepped onto the moon, if you'd have shown him a digital watch, he wouldn't have understood the technology that went into it. He wouldn't have known how it worked. And it's now forecast that over the next 20 years, there's going to be an even more startling period of change.
We're moving now, or in the early part of the 21st century at any rate, into a stage of benevolent slavery, where people will ride on the backs, instead of on the backs of other people, on the backs of machines.
In the next program, we will look at how the silicon factor will affect industry. The new technology will take over mundane, repetitive jobs, but at what price? Is British industry keeping pace with this micro-revolution? And how much will the chip affect the world in which we work?
And when she did a pas de deux, everyone applauded her. Till Dilys, heady with success, performed impromptu arabesques underneath the royal box, where sat the prince, a handsome fox. Then jumping up on pointed toes, she spun away across the snow. The prince leapt forward with surprise and raised some glasses to his eyes. But Dilys...
There must be better ways to spend a working life. The concept of human assembly lines created mass production. But what kind of fulfillment can there be for human beings mechanically repeating the same movements over and over again? Soon, however, jobs like this may have to be a thing of the past. This fluorescent light factory in Holland is owned by Philips, the giant multinational company. And in the past few years, the shape of their production lines has been changing. This line was put in 25 years ago, and they still keep it going for a few specialist lamps. Lamps that are expensive because people are expensive. But 8 years ago, this more productive, more mechanized process was introduced for the more popular lamps. About 15 men supervise it, and working flat out, it makes about 2,000 lamps an hour. But it's now old technology. Things are changing again to this. It's a similar machine, but the new technology of the silicon chip has made it possible, virtually overnight, for the same 15 people to double their output. At 4,000 an hour, it's so fast that the men on their own couldn't keep pace with it. So now there's a new kind of supervisor, the computer. Every part of the process is monitored with sensors which report to the computer about faults or failures even before they happen. When the computer reports that something's up, the men can put it right. This has reduced the number of stoppages, reduced wastage. Of course, it's a long time before a machine will do every job in a factory, even one like this. But most of the jobs here are becoming more skilled, demanding more from the brain and less from the muscle. When this comes fully into production, other manufacturers will feel the keener wind of competition unless they too have used this new technology. Philips is big, very big, with over 400,000 workers, many of them in Britain. But even huge multinationals like this have been coming under pressure. Philips is in the electronics business, so are the Japanese. Their electrical products have been flooding markets all over the world.
Their products, as a rule, are reliable, good, and not too expensive.
Is this a threat to you? Is this a threat to you?
Yes.
And what do you need to do in order to fight off this competition?
Well, first, to be at least as innovative as they are. And also, it's not sufficient to have this information in your laboratory to bring it rapidly to the market. And in order to bring it rapidly to the market, you have to use efficient manufacturing means. You should not be afraid of mechanization or of investing in more sophisticated machinery in order to make your manufacturing process as competitive as possible. For that's the thing they are doing.
Even in Eindhoven, Philips's hometown, employment has been falling. New technology, introduced to keep the company competitive, has been the cause. If it's not to go on falling, the company must look to new markets or new products.
So, who might sink or swim in the marketplace? Because right now, huge multinational companies in Europe, Japan and America are competing for your business, for the money you'll spend in the high street over the next 10 years. This particular machine is Dutch, and it's using two new technologies, lasers and microelectronics, and it'll open up entire new industries, factories, shops, and perhaps thousands of new jobs, and also opportunities for people who make programs, because it's really a gramophone record for television, and these discs are pressed just as cheaply as the conventional ones. You'll be able to buy one in a shop, put it on a machine like this, and hear the sound of your favorite pop group, symphony orchestra, or of a sporting event in stereophonic sound, and at the same time see the pictures on television.
The laser fires a tiny beam of light at information stamped as dots on the disc. The light is reflected back, and the fluctuations turn into the electrical signals needed to make the picture. It doesn't matter if the disc is distorted, the microelectronic controls keep the laser beam exactly on course.
This also uses a laser to replace the conventional stylus on your record player. It's a mock-up of what your record turntable could look like in the early 1980s. It's basically using a new technology to improve an old idea, how to get sound or music from a disc. And if the idea does catch on, then it could alter the whole shape of the industry, the people who make conventional styluses, record players, and the records themselves. Chips or small electronic circuits inside here enable them to produce a machine this compact and this small. And the disc itself is virtually indestructible. It doesn't matter whether you scratch it, drop it on the floor, or rub your dirty thumbprints all over it. It won't matter. The laser will beam right through the dirt and pick up the sound. The quality of that sound is likely to be superlative, better than anything we've ever heard before. And because the laser never touches the disc, it won't wear out.
Companies like Philips, big as they are having to use the new technology in order to survive. This derelict factory on the North Circular Road outside London is a memorial to a once successful company which failed to realize that because of new technology, the world had suddenly changed.
Gross was a family firm run by two brothers, and at one time they made these good old-fashioned solid mechanical cash registers. The firm really took off in the 1970s with this machine and the introduction of decimal coinage. But time was running out for this old established firm. New electronic cash registers were flooding the market, mainly from Japan. They were cheap, reliable, easy to service, and they did a multitude of jobs. Well, here they understood all about mechanics, not electronics, and very soon the firm began to go bust.
What saved Gross Brothers from total extinction was a takeover by Chubb, the security firm. And Chubb realized that the company's products were hopelessly out of date. What the new owners did reveals what may be in store for literally thousands of firms in Britain and millions of workers. First, the management realized it must introduce a new machine based on electronics and not mechanics. It was the only way to keep the firm alive.
Quite simply, we would have become more and more uncompetitive, and we would have gone out of business. We had no other option but to either compete on those terms or to leave the business. Now, we are not prepared to do this. We're the only British cash register company left. We've got a lot of experience of mechanical cash registers. We've got a large labour force here in the factory, and we, after a lot of heart searching, decided that the only way we could go forward was to produce our own microprocessor-based cheap cash register.
This explains why. The old-fashioned mechanical cash register needed about 3,500 components to enable it to do simple things like add up, subtract, and give you your receipt. The kind of things you take for granted when you're paying for your goods at a supermarket. Well, now with the new micros, all this will be replaced by this. Just 600 components, 2 circuit boards, and a few silicon chips. The firm buys them at the moment from America for £18, but soon they may only cost a few pence. Now, this enables them to produce a machine like this, a micro machine, cheaply, thereby competing with foreign imports.
Yet Chubb had taken over a company with a manufacturing tradition based on making mechanical parts. So with fewer parts needed for a machine based on micros, it clearly meant fewer workers too. The next step was to carry the workforce with them. It was a stroke of brilliance to organize a trip abroad for a party of shop stewards. Chubb took them to a cash register trade fair in Germany to see what the competitors were putting on the market.
My first reaction was, God, we're way behind times, because the machine that we were making at that time was obsolete compared to what we saw there.
And you were convinced then about what?
Well, it convinced me that the company that had taken over would have to go into the electronics field very, very quickly, and they'd have to bring out a new machine basically to catch up with the competitors, and that was just to catch up.
Did you have a hard job selling it to the workers when you came back?
Yes, because basically they hadn't seen what I had seen, and they still had fears about how many people were going to lose their jobs and what was going to take part in the new machines, whether it would be actually feasible or not.
Now,
but I was convinced it was necessary.
Of course, some people have had to go. There have been redundancies. After all, if the mechanics, which take about 8 hours to assemble, are now going to be replaced by this little chip, then fewer workers are needed. What's happened to this firm could apply to companies all over Britain, whose manufacturing process is based on making mechanical parts. Chubb's finally got it right. They're now in the electronics business, whether they wanted it or not. Gross went out of business. But how many other British firms have realized even now that the manufacturing world is facing its biggest upset since the Industrial Revolution 150 years ago? In the past decade, the introduction of the microelectronic computer, the silicon chip, has changed the whole concept of how industry and those in it will work, and it'll mean a major rethink in Britain.
Okay, the next operation is...
It's everywhere. A new age of control, brought about by sudden access to miniaturized electronic circuits, computers on a tiny chip. Hornby, the name's been synonymous with model railways for years, have been fighting off fierce competition from foreign manufacturers, particularly the Germans. So the companies turned to the new micros to create a revolutionary way of controlling model railways.
Why did you need to develop this system?
Well, we basically felt that the industry needed something different. You had to bring more operational realism into trains, and this is the only way you can do it.
How does it work?
Well, essentially you have coded electronic signals that are mixed with power, and you feed them down the track. The train picks up the signals, controls the speed as it's commanded from the master controller. You just have 2 wires from the master controller, and that's it. In a conventional layout, you probably would need the equivalent of 1,000 wires. It enables you to control speed and direction of up to 16 locomotives.
Yes.
You can also control up to 100 points or ancillaries.
This kind of control, and you wouldn't have been able to do this a few years ago, is very important to Hornby, because the company now believes its future is more secure. Unfortunately, the number of examples of British products using micros like this are small. Toys and cash registers are rare exceptions.
I think it has to be an almost instinctive reaction of any designer of any consumer durable, for example, to think automatically about the microprocessor as a way in which he can make his product better.
Microelectronics can help everywhere in industry, starting with the design of parts. At this firm, electronic drawing boards help to create the complicated shape for a car's side lights. A microcontrol model maker makes a prototype from information supplied electronically direct from the drawing board. And in weeks rather than months, the concept can become the finished product. Lucas designed a control system to monitor the gases in a furnace heat-treating diesel parts. This British invention, using microelectronics, is simply fitted on to the Swiss-made furnace. The old rule of thumb way of controlling the gas mixture has been replaced by more exact, continuous microelectronic control. The failure rate has fallen from 30% to nearly 0. The furnace works faster, it saves energy. But again, the number of examples of this kind of application in Britain is small.
Well, the basic national problem is we are not training enough good electronics, mainly good electronic systems engineers, good software people, and even good old-fashioned solid-state physicists. our universities and academic institutions are just not turning out enough. They're turning out about 25% at the moment of what we really need. Secondly, we have, as I say, been short of the funding in industry necessary to plough back into this very difficult area. And thirdly, I say many of our good people have gone overseas, the people we've already had. So those are three main difficulties that we have to contend with.
But Lucas is a big company. It's got the resources and the know-how. Most people, though, work in small companies. So what about them?
Being slow-moving.
But not
Because if you move too quickly, I think in some situations you can lose out.
But not
That is definitely not the case with microelectronics.
It so happens that the Americans have probably got a 10-year lead in the whole field, across the whole field of electronics development, from the chips themselves right across to applying the chips and the microcomputers into advanced systems.
Just the Americans?
No, the Americans are preeminent, and of course the Japanese have had enough sense to get along very quickly behind.
Why are we so far behind?
I think basically because the environment in Great Britain has not been very conducive to running and working hard in this type of field.
Outside Britain, other countries seem to have met the challenge of the new technology faster than we have. In Sweden, robots are now becoming commonplace. Proportionately, there are 30 times more of these machines in use than in Britain. The one British robot manufacturer sells nearly all his machines abroad. British industry doesn't want them. This one's operating within a big company, so the comparison with Thamesmead is unfair. But it's working in a small space, making the kind of products manufactured by little companies. It's replaced the work of 3 women who used to manufacture the parts this way. In comparison with the human workers, the machine doesn't need a tea break. It can work 24-hour shifts if necessary. Unlike the women, its health won't be affected by the dust in a confined space. Its arms won't suffer any aches or pains, and it's totally flexible. It'll do a wide variety of different jobs. Robots are becoming cheaper than human beings. The perils of industry ignoring this revolution are plain enough to see. Even more uncertain is what the change will do to people. The human being is a fragile creature. Unlike robots, people have feelings like resentment, pride, jealousy, and above all, the instinct for self-preservation. And here, where machines now weld together Saab cars in Sweden, humans are disappearing. By far the most important challenge now facing industry is how to accommodate people and machines. Managements who want fewer workers, workers who'll do different jobs, or no jobs at all if machines do it for them. Once, this man was a skilled welder. Now he watches a robot doing his job. Men are still needed. Machines break down. About twice a week, they have to move in and repair them. Right now, this man likes his new job, watching instead of doing. Right now, because he's still got a job to do.
This is much better.
This is better?
Yeah.
Why? In what way?
Because there's not so much physically work. You have not to lift anything, and yeah, it all goes automatically.
Is it a little bit more boring for you?
Some jobs, yes.
Already in Britain, conflicting attitudes between management and unions over what to do about the new technology has resulted in several appalling confrontations. The strike at the Times, which put the papers off the streets for nearly a year and cost Thompson's £30 million, began when management wanted to introduce new computer control machines. The unions worried about who was going to man them and who might eventually lose their jobs. There are grave doubts whether the fragile industrial relations in this country are in any shape to cope with the new technology, whether what actually happened here may be just the beginning.
What's your opinion about the relationship between management and unions in this country vis-à-vis the new technology?
Well, there isn't one. I regret to say it. I will be put in a position, almost certainly, unless attitudes change, in 12 months to 2 years' time, where I'm going to be an unwilling Luddite. I'm going to have to tell my members, and other officers of other unions are going to have to tell their members to resist technology, because we can't come to arrangements to put the thing in.
Why?
Because we're not getting any response from employers.
In Sweden, their rush hour might be the same as ours, but when it comes to the new technology, they're doing things differently. It's a small country with a high standard of living. Like us, Sweden is dependent upon its industrial competitiveness. Unlike us, the unions and managements are learning to cope by working out the ground rules together.
You can sit down, 10 or 15 people together in your own working place on paid working time and discuss our aims and discuss how you should negotiate with the management about these things.
Now, what's the purpose behind it?
The purpose is that we should be able to negotiate with the management about how computers should be used, so that we, after this negotiation, can tell the technicians how they should work, what they should do.
In other words, giving you the same kind of power as management to control the technology.
Yes, that's correct.
The important thing is, as I see it, that we can arrange so that the employees and their trade unions will have a reasonable chance to learn about new technology, to know about which the effects may be. But I think it is as important that employees and their trade union representatives are given new chances to come into this work, to participate actively, and to have a real influence on what is done. And we are bargaining and negotiating on this at the table now.
It is, of course, easier in Scandinavia. Factory workers in Norway have only one union. At this arms factory, where microprocessors have been introduced into the manufacturing systems, workers and management monitor, indeed control, the changes this will bring. And they do it together. The Norwegians have approached the problems posed by the new technology in a way which many believe to be a model for us all. The right for workers to be informed about technological change, to know as much as management, to be consulted at every stage, is now written into the Norwegian trade union agreements. This man, a union representative, now has another title. He's a data steward, responsible for negotiating with management on all aspects of technological change.
Of course, the reason for this is not only because
it's part of the attitude which has developed since the war, but it's also because experience shows that if you can create the right atmosphere, you can increase productivity much more than by any system. Any system can be sabotaged. And if you have unwilling people and people who are not interested and don't see their own good and see what's a fulfilling of their needs in the system, you are hopelessly lost in this world anyway.
I think this technology is a very good technology. We shall use it. So I think our work is on how it should be used.
I want it. I know that we need it. But the point is, unless we can get together with management, unless they can change their attitudes and trust unions and trust us with information, then we are just not going to have this technology in.
What will we do with them?
If we don't get cooperation, there must inevitably be, unfortunately, a larger number of disputes in industry over bringing it in. I think it very regrettable. I think it very, very avoidable. It's the easiest thing in the world to do what the Norwegians have done, have a series of technology agreements, which is what the TUC are trying to and suggesting we negotiate. My particular union is trying very hard to negotiate.
And the response?
So far, absolutely zero.
If we don't move now, and move very, very quickly, both large and small companies alike, I think we run a major risk of losing competitiveness across many, many of our product areas and service areas.
We still have time to stay in this race. If we run very hard now, we've got to work extremely hard. We've got to make very logical and very careful choices as to what areas we work in. I believe we've still got a number of years to stay in the race, but we must go very hard now. We must have full collaboration between the government, industry, the university, government research establishments, etc. Everybody has got to march in step and understand what we're trying to do. So there is probably just enough time if we start work now and work like hell.
Proof that industry must change, that attitudes must change, is here. It's in the middle of Holland, in an all-automatic warehouse, devoid in this gigantic storage room of any human beings at all. It's owned by Philips. It's one of the biggest in the world, and it's controlled by a small computer. It doesn't need to be heated. There are no people around to get cold. The lifting, selecting, the filing, the conveyor lines, it's all done by machines. As the cases of light bulbs come in, other cases go out. There are humans here in the computer room monitoring the electronics. But the day is nearly here when man will also be building factories which won't need many men. Prototypes have already been built in Sweden and Japan. So what future will there be for industry? What future will there be for any country and for us if we don't heed the warnings now?
No one really knows what the impact of the new technology will have on jobs or on our quality of life. Already, in isolated examples like this, machines have taken over the jobs normally done by men. In this electrical, mechanical, all-automated warehouse, they're clearly more efficient than us. This is an example, perhaps at its most spectacular, of what the world of the future will be like. And it's something which British industry must be striving for as well. How we come to terms with the new microelectric technology is something we cannot ignore, nor can we shelve it. It's something which all of us must be thinking of right now.